Number 23.
Yeah.
I get confused with like the exponents.
I feel like I put this all out of order. Maybe okay, 23 is right here, right?
Yes, sir.
So 23, I'm looking at, I have two things there. I have a plus between it, so it can't be a difference of squares, so it must be just factoring out the biggest thing I can out of both things. So the first I'm looking at is that 4 and 32. I can definitely pull out a 4 out of both of those. And now I see I have a p to the fourth and a p. That means I can pull at least a p out. And you just have to note that p's in both of these, pull out the smaller one. So I'm just going to pull out p to the first.
Oh, so it doesn't, you don't need to subtract that?
Nope. We're just pulling out p to the first. I have a q in both of them, so I'm just making sure it occurs in all terms. So I'm just going to pull out a q, and I'll write it again, q to the first, the smaller one that appears. So you look at all your terms, and you find the smaller one that appears, and you pull that out. So we go ahead and continue. Well, we're going to have 4 times 8. Nope, I'm on the wrong thing. 4 times 1 would get me, I'll just put a 1 there just to hold this place. P to the fourth divided by P1, you subtract. 4 minus 1 would be P cubed. Q over Q is just 1, so I'm not going to write that. I already have a 1 there. Then we'll have plus, and we'll have an 8. P divided by P, that's 1, so I'm just going to leave that alone. Q to the fourth divided by Q to the first, that's 4 minus 1, which is Q to the third. Now we're going to realize that this is, in fact, a sum of cubes. So I would have to realize that this is actually p cubed plus, and this would be 2q cubed. Okay, do you want me to keep going, or do you think you can do the sum of cubes from here?
Yeah, I'll try it.
Okay, because it's just plugging in that formula, that one that we'll just have a plus b times a squared minus ab plus b squared.
Okay.
All right, other questions? Okay, yeah. What was that? 27? Uh, 27, we have negative 3a to the fourth plus 15a squared plus 108. 108, that's 9. So 3 is going to go into all these. It might help you, it might not. I don't know. I usually like to pull out a negative 3. I don't like my first term to be negative, but it really doesn't affect anything. It's up to you. But that's going to leave me a to the fourth minus 5a squared plus, what do we got there? 36? Or minus 36? Did I do that right? Am I good there so far? Something feels off on this one. All right. This one is another one of those things that I could guess and check my way to the answer because there's no term in front of the a to the fourth. So I'm going to factor it like a trinomial, except I'm going to have a squareds out first. I have a squared times a squared would give me a to the fourth. Now I just need two numbers that multiply together to give me 36. I'm first thinking about 36, but the difference between those two numbers must be 5. Well, it can't be 6 times 6. So we'll go to the next thing. Maybe we look at 8. Maybe we look at 9. 9 and 4. What's the difference between 9 and 4 is 5. So I'm going to use 9 and 4. One of them needs to be negative. One of them needs to be positive. The 9 has to be negative to keep this negative when I add it. So I'll have a negative 9 and a positive 4. Now I'm going to notice I can go one step further, Jason. I'm sorry. I'm sorry, Guy. So we have an a squared minus 9, which is 3 squared. So I'm picturing this as a difference of squareds. So we can go one step further and make this 3a minus 3a plus 3. And then we'll have a squared plus 4. So we do have to go that one extra step. Okay? Now, I'll note this is a really hard problem if you don't factor out first. If you don't factor that negative 3 out, it becomes a much more difficult problem because you have to factor it out later. Bless you. Yeah?
10, I got a different...
Oh, yeah, 10 is wrong. Yeah, we went over that in class just before you got here. 10 should be x plus 7, x plus 5. Yep, if you email me, you would have got a point.
Oh, we can do that? Yeah.
Yeah. All year. Okay, other questions? Okay, then I'm going to get to what I don't think it's necessarily the hardest lesson out of these before the quiz, but I think it can be for you, just because of some of us that aren't doing the homeworks, that this is everything put into one that we've been doing so far. Basically, that last lesson put into this lesson. And we're going to talk about rational expressions. A rational expression is a fancy word to just say we have a quotient. That means we're dividing. We have a quotient of two polynomial expressions. So I can't have like 3 over 4. I guess you could call 3 over 4 a rational expression. Yeah, that would work. So basically, if we have a division, we have a rational expression. I do want to point out 2 little things that are going to show up and I'm not going to show a whole bunch of work for. First of all, if I have x plus y over y plus x, they're all pluses, so we should be able to realize that this really is x plus y over x plus y, because I can do that, which would be 1. The weird one is when you have the exact same values, but they're flipped. If I have x minus y over y minus x. This would be the exact same thing as if I had x minus y, but I pull the negative out of the bottom, and I have negative 1 x minus y. Because when I pull a negative 1 out, it flips both of the signs. So when you have x minus y over y minus x, this is just going to equal a negative 1. You can do all that work, but I'm just telling you right now, in the lesson, when I get something like that and I circle it, I'm just going to say it's negative 1, and this is why it's negative 1. I'm also going to preface something before I do this lesson as well. I will not be factoring. I'm going to skip the factoring step. You guys can do the factoring step. I didn't leave myself enough room to do it. On the homework, I gave you plenty of room that you could factor off to the side and then come back to it. So I don't have the room, and I also taught you how to factor. So I'm going to skip steps. I'll let you know when I'm skipping steps. Know that I'm just not supporting my work, but you guys, I trust that you could if you're doing the homework. Are we clear on that? So at times, I will tell you we're skipping steps. That math is happening. I just don't have the room to show you or the time. Good? Okay? And that happens right off the bat. Now, when we are doing rational expressions, I'm really telling you we are going to factor. Honestly, this is the exact same thing we did the other day. We're going to factor, and then we're going to see what happens after we factor. So whenever you get a rational expression that looks like this, the first thing I'm asking you to do is factor. So that means we have to look for difference of squares, sum of cubes, difference of cubes. We have to look for trinomials that can be factored. Those are the big things we're looking out for. So it's just like those last parts of our homework where just say factor completely. So if I look at this first thing, I see this 64k cubed minus 1. I'm thinking difference of cube. Because I do have this cubed here, and we need to start recognizing that 64 is a cube. So what I'm picturing here is this is really 4k cubed minus 1 cubed. That is a difference of cubes. So before I do anything else, I'm going to plug it into that difference of cube formula. The difference of cube formula says do this, and we have a subtraction, so it'll be this minus this times a squared minus a times b. I think I flipped that up. So let's just write it down. Otherwise I get lost in my own head. So we're going to have the first term 4k minus the second term, which is 1. Then we're going to have the first term squared. Remember, we're squaring the entire thing. So it's 4k times 4k. So I'm going to have 16k squared. I started with a negative sign. We switched to a plus sign. Then we do our a times b. That's 4k times 1, which would be 4k. Then we're going to switch back to a minus, and we're going to have this 1 squared. 1 squared just remains 1. You can write it as 1 squared. I don't care. I'll even write 1 squared because I'm talking about it, but we should know that's just 1. If it helps you remember the formula, you can write it down. Here's where I'm going to skip steps. This bottom one is factorable. we can factor it into a binomial times a binomial. Here's a good rule of thought. I picked these equations specifically so things can cancel out. See this 4k minus 1? More than likely, this is going to break down into a 4k minus 1. It's a good rule of thought when you're factoring it to see if it's correct. Something should cross out. I'm not going to give you one that's just not solvable. It's not reducible because that's a waste of time. Because you're going to be on the quiz, you'll be on it for 10 minutes. Maybe, Mr. Pabian, this one doesn't go anywhere. I'm like, ha, gotcha. That's not my goal. I'm looking for things that are factorable. So this 4k squared minus 13k plus 3 actually reduces down or factors to 4k minus 1 times k minus 3. Now, obviously, if you were doing this, you'd have to show more work. So there's like hidden work here. So I'm skipping some work. Some math yoga happened here. Some of us might be able, taking that hint, knowing that this is usually going to cancel out with one of these two, you could maybe guess and check your way through it because you're like, okay, I think this is one of them. Let's see if I can figure out the other one. All right. So now what we can realize is that parts of this cancel out. It's connected by multiplication, so that 4k minus 1 cancels out with that 4k minus 1. Then we have 16k squared plus 4k minus 1 all over k minus 3. I'm going to tell you right now, this is not factorable. You are done. You simplified it as far as you could. So today is really, I'm just asking you to factor. Factor and cancel things out. That's the name of the game today. That's why we needed to do that homework last time. Yeah, go.
This is just a simple question. Will you count off when you don't have parentheses?
If you don't have parentheses here, you should just so. Okay. Without parentheses is a different problem.
Okay, fair.
Yeah. Because without parentheses, I don't know what you have to do first. Parentheses tell you that these stay together. So do have parentheses.
Okay.
All right, our next one, what I'm looking at there is if I need to simplify it, I know we might be geared towards looking at difference of squares, but I always tell you should factor out the biggest thing you can out of it first. So I probably should have looked at here. I couldn't have factored anything out of any. We're good. Can I factor anything out of 1248? I can actually pull out a full 12.
Yeah, 12 and n, right?
All right, yeah. Is there an n in all of the terms in the numerator? That means I can pull out at least an n. You look for the smallest power. I have n squared, n to the first, so I'm going to pull out 12n. That's going to leave behind, well, 12 divided by 12 is 1. N squared divided by n is n. I'm going to leave n in that place. When I pull this out, I'm left with n. 12n times n, giving me that 12n squared. Okay. 12 goes into 48 4 times. And the n's cancel out, so I just have n minus 4. Oh, this isn't even a difference of squares. Like if you thought it was a difference of squares, once you factored out that greatest common factor, oh, my life became a lot easier. That's why I always tell you pull out that greatest common factor first. Is there anything that goes in 288 and 18? 18 goes. Ooh. You know what's great about having a calculator? Bless you. It makes this problem a lot easier. Do I ever tell you you can't use a calculator? No. Because I'm telling you, if you learn how to use your calculator, if this was like an AP class, I might tell you not to because people use their calculators as a crutch. We just don't use our calculators enough. So I strongly encourage you learn how to use your calculator. It makes all these problems a lot easier.
16.
Yeah, 18 goes into 288, and it'll be 16 times. Is there an n in all of the terms?
Yes, you can take out 2n.
I can actually take out n squared, because that's the smaller one. All right, you said it went in 16 times, right?
Yep.
And we'll have n squared divided by n squared, so that would just give me 16 is all by itself, minus 1n squared.
Wow. Did you just put n squared?
You could just put n squared, yes. This is more just for your notes that you understood. Sometimes I might put one because I'm not sure if it's going to cancel out, and I might have to leave that one there, but you can figure that out. You'll know because it'll be the exact same thing. Yeah, go.
And then you can break up the second part
I can break up the second part. I think you mean the 16 minus n squared, right?
into the
because it's a difference of squares, right? That this one right here is really 4 squared minus n squared, which is a difference of squares. So we can now rewrite this as 12n times n minus 4 all over 18n squared times the difference of squares says we're going to do 4 minus n, and we're going to do 4 plus n. This is where we have to have our, I guess, spidey senses tingling that these look very, very similar. I have 4 minus n, and I have n minus 4. That was the one I said I'm not going to spend a ton of time on, but we need to start realizing that this is equal to negative 1. That is equal to negative 1, as long as it's the same negative between both of them, and they're just flipped. So I look at that, I have n minus 4, and I have 4 minus n, that equals a negative 1. So that means we can actually cancel those out with that negative 1 and just throw a negative out front. No, it's just one negative. You can put it on the top, you can put it on the bottom, or you could put it right smack dab in the front.
Okay.
We're just adding one negative sign out front. Now, we should also realize that we can reduce this 12 and 18. This 12 and 8, 6 goes into both of those, right? So let's put this negative sign out front so I don't forget about it. 6 goes into 12 2 times. I'm going to put a big thing here. 6 goes into 18 3 times. What about n divided by n squared? It would just be n on the bottom, right? Because that's the bigger one. So I'm going to go ahead and circle those in maybe purple color. Just say, like, I'm focusing on these guys. That's going to cancel out an n and just leave an n on the bottom.
Oh, so the top end cancels out, so it's just only 1.
Yeah.
Oh,
yeah.
Okay, yeah.
And then we have just 4 plus n down here. So I really could have moved that 2 over, but I don't care about the semantics.
Do I just because you divided it?
Oh, I just divide. In my head, I simplify the fraction. We don't actually put 6 down.
Oh, okay.
Because if I gave you, like, if I'm just like simplify this fraction, what is it, 12 over 18?
Oh, yeah.
In your head, you are dividing by 6, but you're just writing out the 2 over
Okay, yeah.
3. So that's where that 2 over 3 came from. So I'm really just asking you to factor and cross this out. That's this whole lesson, is factoring and crossing stuff out. That's why it was really important. I told you guys, you have to keep up with the homeworks. Because if you're good with the homework that's due today, this stuff's pretty easy, because some of the stuff you can do in your head and you kind of start remembering those differences of cubes and stuff. All right, if I ask you to multiply or divide, it turns out it's the same rules. Factor first, see what cancels out, and then do the multiplication. Because right now, if you don't factor, imagine how hard this problem is. I'm gonna show you it right now, really, really shortly. If I don't factor this, I have to distribute this to everything, 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 and then try to factor things out and stuff. That seems like so much work. I don't want you to do that. I want you to factor first, see what crosses out, and then do your multiplication. So once again, I am going to skip some work. I'm going to tell you right now what this factors to and what this factors to. So I am skipping work. Our top one of that first thing, so that 5p squared plus 29p minus 6, factors down into 5p minus 1 over p plus 6. Obviously, if this is the homework, we couldn't skip those steps because we probably can't do that in our head. So once again, I am skipping steps. I am doing what I call math yoga. It means I'm doing stuff in the backgrounds. I'm doing some math yoga, and I get out that. So I'm not actually showing you the work. I'm just skipping the work. Same thing on the bottom. I'm going to skip the work. Usually we do our AC Beyonce column, do all of that work. I'm not going to for the bottom as well, and that's going to reduce down to 5p minus 1 times p minus 5. I am going to do some work here because the first thing, First thing you can think about is difference of squares, but before you think about difference of squares, see if there's something you can pull out of both those. Is there something I can pull out of 3 and 15? Yeah, I can pull out 3. The thing that always tells you I should have pulled out the greatest common factor is if you have a same variable in all the terms. It meant I should have probably pulled something out. So we're going to go ahead and not put an equal sign. We're going to put a multiplication sign, but we're going to put a 3 times, and I can pull out a p. 3 times 3 divided by 3 is 1. P squared divided by p is going to be p to the first. Minus 15 divided by 3 is 5. P divided by p is just 1. We should realize that 36 minus p squared is a difference of squares. Can someone tell me how to rewrite 36 minus p squared? 6? I agree with 6.
Minus 6 minus p and 6
P and then 6 plus p. Yep. All you have to do is just figure out what the square root of 36 is, and it's 6. That's going to be your, yep, because it'd have to be 6 squared. All right, now you're looking for things that can cancel out. It's all attached by multiplication, so we can cross out that 5p minus 1, that 5p minus 1. I'm also going to notice this p minus 5 and this p minus 5.
And then
What's the second one I'm looking for? P plus 6?
It's negative. It's just p plus.
I heard p plus 6. Is there one that's close to p plus 6?
6 plus p. Yeah.
Is 2 plus 3 any different than 3 plus 2? No. So these right here, I'll circle them. Even though they're in different order, it means the same thing. 3 plus 2 is the same thing as 2 plus 3, so those cancel out as well. And what are we left with?
3.
We're left with 3p divided by 6 minus p. I promise you, if you distributed it, you would never get there. It's so much work if you would have distributed first. Yeah, go.
I guess I just got confused. How is that like not like positive 1 when like before we got like negative 1?
How do we get negative 1? Let's look at the one we got negative 1 out of. We got negative 1 out because n minus 4 is not the same thing as 4 minus n. 3 minus 2 is not the same thing as 2 minus 3. Okay? But it'll leave behind a negative 1.
Okay, so if it was minus, then it would most likely be a negative 1.
It'd be a negative 1.
Okay.
So if they're flipped and it's a negative sign, we replace it with a negative 1. If it's flipped but a positive sign, we replace it with a positive 1. Negatives tend to lead to negatives, so just think about in your head what would happen if you plug numbers in there.
Yeah.
And you can even plug numbers in just to double check.
Yeah, that's cool.
So if you're not sure, plug a 2 in here. 2 plus 6 is 8. 6 plus 2 is 8. It has to work. And 8 divided by 8 is 1. You could do the same thing here. If I plug a 2 in here, 2 minus 4 is negative 2. 4 minus 2 is a positive 2. Negative 2 divided by 2 is a negative 1. So if you're not sure, just plug in a number. Okay. It has to work. It has to work for all numbers, so just pick a simple number and see if it works. So if you're ever just stumped, plug in a number and see if it turns out to 1 or negative 1. If it doesn't, leave it alone.
Okay.
All right, dividing. I'm not going to do the full dividing because you guys get what I'm doing here, right? The only thing I'm going to start with dividing is instead of dividing, I'm going to do keep, change, flip. So I'm going to change this division sign to a multiplication sign, and then I'm going to flip these. So rather than doing what I was given, I'm going to have 2s squared plus 9s plus 4 divided by 1 minus 4s squared. And I'm going to change this to a multiplication sign, and I'm going to flip those. I'll have 2s squared minus 3s plus 1 all over. The top one was 2s squared minus s minus 1. I will take a second and talk about what I would do, though. We have some trinomials here, right? So I'd probably have to factor those. What would I use here? Look at that 1 minus 4s squared. What would I use there? What could I use at 1 minus 4s squared to factor it? We know it's not a trinomial. We would use difference of squares because this is 1 squared minus 2s quantity squared. This would be a difference of squares. Start recognizing when you have to use difference of squares because that can be hidden in there. And if you miss a difference of squares, you miss something that will cancel out. And it becomes a much harder problem, especially with multiplication. With multiplication, look at this one. Did I ever need to multiply anything? No. Most of the time, it's almost nothing or just a small amount. If you're doing major multiplications on these problems, you probably didn't simplify it correctly. So it might be a time to stop, move to the next question, and then go back to it and try to simplify it again. Or raise your hand and say, Mr. Pabian, I am doing way too much work on this. Does this seem right? I'll probably tell you no. All right, questions on multiplication or division? Oh, I did for this one?
What's the second term in the
Here?
on the bottom on the denominator? Is that it?
That's an S. I took to these and flipped it.
Oh, shoot, okay.
You don't have to look at mine. All you do is take these two and you flip them.
Okay.
So I put this one on top, this one on bottom. That's why I have those arrows.
Oh, shoot.
So you shouldn't have to copy mine. You should just look down at yours. All right, rewrite with a common denominator and combine. That's what we're adding or subtracting. They have to have a common denominator to subtract or add. So if you remember my tip, for whenever you're adding or subtracting fractions, you can always get a common denominator by multiplying by the other denominator. You can always get a common denominator by multiplying by the other denominator. So if I have 1 over 3 minus 1 over 2r, and that's why I gave us plenty of room on both sides, I'm just going to multiply the 1 over 3 by 2r over 2r. I'm going to multiply the 1 over 2r by 3 over 3. I just use the other denominator. That's it. Just use the other denominator. If you're not sure what to do, use the other denominator. Okay, so that's going to give me 2r over 6r minus 3 over 6r. Bam, sis. We have a common denominator. If it doesn't come out as a common denominator, you did something wrong. All right, continuing on. Move the negative to the top because when you subtract, you smush together your denominators. You should just have 6r on the bottom. On top, we're going to have 2r minus 3 over 6r. Excuse me. Okay, now I said the fail-safe is multiply by the other denominator. It doesn't mean that's always the easiest way to do that. Because if I look at this one, if I multiply the top by 4w or 5w over 5w, and I multiply this one by 4w over 4w, I'm going to create w squareds that I don't need. Notice how we have w's in. Would you get the correct answer? Sure. You just have to do some simplification on the back end. But what would be smarter is realizing that w is already taken care of. I have a w in both of them. The only problem is the 4 and the 5. So I'm not going to multiply by a w. Instead, I'm just going to multiply the top and bottom of the first one by 5. I'm going to multiply the top and bottom of the second one by just 4. Because now I'm picturing, okay, 5 times 4 is 20w. 4 times 5, that's 20w. That will create my common denominator without creating unnecessary variables or numbers. So we are now going to have 15 over 20w minus 8 over 20w, which is going to be 15 minus 8, which is going to be 7 over 20w.
We have more of these.
Right. We will. They're just going to be a little harder.
Oh, good.
You asked for it. I will give you more of them.
Let's go.
Let's go indeed. Hey, nothing changes here. Nothing changes here except for one big fact. You don't always have to multiply both equations by a number. So if I picture this is a fraction minus a fraction. This is 2x minus 1 over x plus 4 minus 3 over 1. If I multiplied by both denominators, I'd multiply this one by 1 over 1. That doesn't change anything. So realistically, I'm just multiplying the top and bottom of this one by x plus 4. Now we're multiplying by the quantity x plus 4 over x plus 4. That's important because I need to distribute this 3 to both of those. It won't just be 3x plus 4, it'll be 3x plus 12. So we are now going to have, the first one stays the same, 2x minus 1 over x plus 4. We're going to have minus 3x plus 12 is incorrect, but we'll hold on to that for a second. I'm telling you right now, plus 12 is incorrect. 3 times 4 is 12. Why is it not plus?
Oh, it's negative.
It should be a negative 12.
Oh, because then we just keep it, then we make it.
Because you should have kept, and I always circle the negative along when I'm distributing something. I need to distribute that negative to both of them. So it's negative there when we combine these together. So right now we can leave the negative sign there. But we need to realize that this negative goes to both of these when we combine these together.
Negative 3x.
So we're going to have on top 2x minus 1 minus 3x minus 12. So you can either change this to a plus and put new negative signs on there, but realize that eventually it's going to be a negative 12. Because that negative sign must distribute to both of those. And that is over x plus 4. Combined like terms, I have 2x minus 3x, which would be a negative x. Negative 1 minus 12 is a negative 13 over x plus the old quattro. I think I'm just going to do number 8. Number 8 gets number 9 down. I would like to get you started on your homework. I did pare down your homework. I think I maybe put 10 problems on there.
Yeah, with a lot of space.
With a lot of space.
Yeah, the other ones are kind of hard to keep.
I know. Yeah, if you didn't have space, you could always put it on a separate sheet of paper too. All right. So I'm just going to go to number 8. We're just going to do that one. Now, remember how I said we can multiply by the other denominator? The rule doesn't apply that you need to first look at, so if I look at r squared minus 25, something should stand out to me. It's a difference of squares. So I should probably factor it first just because I see that these are similar. Just like if you look at number 9, q squared minus 7q plus 12, that probably means factor that first. So we're going back to the rule that if I see something that's factorable, I should always do that first. Nothing before was factorable in this kind of adding or subtracting, but suddenly we have something that's factorable. Factor everything first, always. Always look for something you can factor first.
Could you change the other one to that one?
We're going to, it's going to be,
And then you can multiply it by r.
yes,
Plus
that's the whole point of factoring it.
5.
Because I don't want to multiply both sides by r squared over minus 25 and
No,
multiply.
I meant the other one.
Yes, that's what we're going to do.
Oh, okay.
Like you're already seeing in the future what we're going to do.
Okay.
I just don't want us to accidentally have r cubes and stuff.
Oh, okay.
Because you're looking at what's going to happen when we have r squared minus 25 and we factor it, right? Because we're going to have r plus 5, and this is going to turn into r, what do I rewrite r squared minus 25 as? R minus 5,
Plus 5.
r plus 5. At least you have one person that's going to do well on this. Plus 6 over r minus 5. Now, here's the good thing about factoring this. I actually don't have to multiply anything. You could multiply the top and bottom of this one by r plus 5, combine it, and work your way through this. But what I'm going to notice is we already have an r plus 5 over an r plus 5. That will cancel out. Don't forget to put a 1 on top. Don't put like a 0. And suddenly we have r minus 5. I just have 1 plus 6, which equals 7 over r minus 5. Adrian was talking about, before we got here, he's like, oh, okay, this is actually r minus 5 times r plus 5. He was just looking at, well, I could have multiplied this top and this bottom by r plus 5 to create a common denominator. You might have to do that. Sometimes this doesn't cancel out, and you have to multiply the top and bottom by r plus 5. But multiplying the top and bottom by r plus 5 is a lot easier than multiplying both sides by r squared minus 25, and then this one by r minus 5, and you have this r. You're just making your life too complicated. So I think the rule today is always look to factor first. Always look to factor first. If it looks really complicated, trinomial. If it looks like you're subtracting, you're adding two terms, look to see if you can pull out a greatest common factor first. Then look for, is it a trinomial, or is it a difference of squares or difference of cubes? It most likely will be one of those cases. So factor first, and then worry about doing anything else second. All right, questions on anything we covered? All right, once again, this is just based upon